Good afternoon. So today our topic toxicology. So toxicology is nothing but the science of poisons so that it affects the human life and so that all the texts as per the science we have seen that the Paracelsus is the father of toxicology. So he said that so whatever the drug we are using, so they are making it into poisons. When the drugs are to be used, right? So the side effects, all the adverse effects, and the poisonous effects, the drugs and treatment, which gives the problem for the health that comes under the toxicology branch of sciences. So here we are going to see there are so what is toxicology, what are the types of toxicology, and then we are going to see this so what will be the effect of poisons, substances on the health. Okay, let's see what will be the subacute and acute and chronic toxicology we are going to see here, and what will be the principles of poisoning we are going to see. And these are all the topics of which comes under the sixth semester B Farm and Farm B third years in the form of. So I'm sharing my screen. So just I'll glance about the screen from the presentation of this school. Right here, see. So acute, subacute, chronic, and toxic. We have said that. So before going to that, we are going to have a glance about that. The term toxicology has been derived from the Latin and Greek word. It is called poison. That means this Greek word poison is a arrow poison. In Latin word it is a nausea and study of science. So the branch of science that is concerned with the nature, effects, and detection of the poisons. So toxicology gives that. So by studying the toxicology that, so we know that easily. So how much extent the drugs will work and what will be the toxic effects and what will be the adverse effects of drugs when are to be used in overconsumption of drugs. So I already said that. So toxicology. So Paracelsus is the father of toxicology. He said that so all the drugs are the toxics or all the drugs or the drugs are getting the poisons when they are affected or used in the normal. So as per that, so let's see the principles of toxicology that those response relationships and then chemicals that enter the body and actually these are metabolized and excreted in major health outcomes of intoxications. The basics of physiology, toxic and cellular toxicology. Let's see. So, whatever the toxicity is of majorly, the concern of toxicology is divided into three parts. That is acute toxicity, subacute toxicity, and chronic toxicity. So, acute toxicity very well known that so chemical for not more than 24 hours, it shows the acute toxicity. And then if it and subacute toxicity, so it is defined as a repeated exposures to a chemical for about 1 month or lesser. And when it comes to subchronic, it can be defined as exposure to the chemical for 1 to 3 months. And the chronic, it can be defined as exposure to a chemical for more than 3 months. So here, so we are going to, as per the pharmacology, as we want to study the toxic of the drugs, that means the poison effects of the drugs. So we going to study that these drugs will show the effects whenever used into the huge doses. So if you are going to study the toxicity of the drug, we have to consider that what will be the acute effects and what will be the subchronic effects and subacute effects and chronic effects. And when it comes to the acute toxicity, so it can be defined as exposure to a chemical for not more than 24 hours. So if it is not more than 24 hours, acute toxicity may be effect of chemical produced after administration of a single dose to experimental animal in a period not exceeding the 24 hours. And acute toxicity will be defined as to be 24 hours inhalation. Again, acute toxicity it gives the adverse effects and should occur within 14 days of the administration of the substance. చేయలేం కరెక్షన్ ఏంది ఇప్పుడు వచ్చారు ఇది ఓకే తర్వాత ఏంటి? ఆ? ఆ. So acute toxicity, the examples will be so hangovers for the acute toxicity. That means the effects will be effective for only a shorter term, only a shorter term. So whenever we are going to ingest a drug or a single dose to the experimental animal, and the period will not exceed 24 hours. Okay, and then the causes of acute toxicity will be redness of skin will be observed. Okay, and then swelling of skin and blisters and burning sensation, severe pains, ulcers, and necrosis, and peeling of skin, everything. So when it comes to the experimental toxicology, dosing is done either once in a day or a multiple times, but from first day of the irrespective of total study duration, which might extend to 2 weeks. That means when we are going to perform an experiment on the animal regarding the acute toxicity, we have to observe that, and so dosing should be done once in a day or multiple times. But from first day respectively, the total study duration might be it have to extend for 2 weeks. Extend to be 2 weeks, and the dosing should be in a 1 week, 1 day, or multiple times of a year. So in clinical medicine, it studies the effect of single dose on a specific animal species. So when we are using the animals, the species should be very reasonably conditioned, and then the animal species to be selected very specifically. For the first time, travel with the scientists they have introduced LD50, that means lethal dose 50. So conduct the acute toxicity study on rats. So in this testing, the test product is administered at different doses for 14 days, after which the biochemical, pathological, histological, and morphological changes are recorded. So here, in the acute toxicity studies, travel has conducted that lethal dose of 50. That means a drug. So up to what extent it will be very lethal? That means it will be very mortal. It will be very mortal when the drug has been ingested. So he identified that. So he has selected the animals, and he have administered different doses of 14 days. He have administered, after which, after administering the drug, he have taken the biochemical, pathological, histological, and morphological changes that has been recorded, and all the mortalities caused by the test substance during the experiment are also recorded. Right? And the LD, so lethal dose was therefore used an indicator. So after that, so after the travel, after that the LD has been now widely used as an indicator for the acute toxicity studies, right? So we all know that LD50 and ED50, that which gives the therapeutic effect or therapeutic window calculations, that which gives the safest form of drugs. If we want to use the drugs, we have to check the percentage safety of the drug. So that so therapeutic index will give how much safe the drugs will be used while we are using for the treatment. So if it is having a better therapeutic index, drug is very safe. Okay. Usually the single dose or multiple dose are given within 24 hours, as an whose toxicity occurs almost within hours after the exposure. So after the exposure, normally a single dose or multiple dose are given even after the 24 hours. So exposure for shorter duration is known as acute exposure. Suppose you are exposing the drug to the animal for about 24 hours, so it will be very shorter. That is called acute effect after administration of a single dose. And then acute acute systemic testing can be described by following guidelines. So acute dermal toxicity, acute inhalation toxicity, fixed dose procedure, acute toxic class method, and up and down procedure. So these and all comes under the testing guidelines that are from the OECD. We all know that Organization for Economic Cooperation and Development, right? And ED50. See what is ED50? ED50 means it is a median effective dose. So which where we can observe that 50% of the animals they will exhibit the half of animals exhibit no effect, right? So the effect may be defined as a specific toxic event that may be a tremors and is sometimes defined as the lethal. Other subscripts will be used to design the percentage of animals are to be affected. So for example, so if you want to identify that, so for example, ED50 and ED90, 10 and ED90 are the doses which are to be 10 or 90% of the animals respectively demonstrate the effect. So this will be the better effect. In the 15 useful of drug. So up to what extent a drug it is to be used for the pharmacological action. Okay. And then next one, subtoxicity, subacute toxicity. Subacute toxicity is slightly more than the acute toxicity. Focuses on the adverse effects occurring after the administration of single dose. So when we are using the doses as a single dose or a multiple doses of a test sample, so per day, even during a period from 14 to 28 days. So subacute toxicity studies are conducted as range finding studies for determining the dosage levels that has to be used to the chronic and subchronic studies for duration of 6 months to 2 years and up to 90 days. So here subacute toxicity said that so after giving the single dose or multiple doses, so we are testing a sample for 28 days. So after giving the drug to the animal, so we are going to see that after 28 days, subacute toxicity studies are conducted as range finding studies for determining the dosage levels. We are going to study the dosage levels of drug that has to be used in chronic and subchronic studies for duration of 6 months or 2 years. Okay, and these studies are conducted for a duration of 2 to 4 weeks in order to evaluate the potential adverse effects of a new drug. So subacute toxicity is used to identify the adverse effects of a new drug. A new drug adverse effects are to be identified so that we are conducting the subacute toxicity. If you want to know the adverse effects of an unknown drug or a new drug, then we are going to conduct the subacute toxicity for 28 days. Okay, and they help in supporting the initial clinical trial phases. The treatment duration might vary from 1 to 4 weeks. So this subacute toxicity will gives you that initial clinical trial phases. That means phase one, phase two, phase three. That while we are discovering drug, we are doing phases, right? The clinical phases. So the subacute toxicity results or reports are used for the so when we are going to the clinical trial, so this will be the basics. This will be the supporting basics for the study of new drugs. So that the subacute toxicity is to be done. And the chronic toxicity. So chronic toxicity means exposure to chemical more than 3 months. Suppose we are giving a drug to the animal, that we have to expose that drug to the animal more than 3 months. So chronic toxicity indicates specific organ system damage. So chronic toxicity indicates that suppose a drug which is to be used very long period, so for a long period. So suppose we are taking the paracetamol. So paracetamol I'm giving a more adverse dosage to the body so that it affects the liver, such like that. So chronic studies are to be used, chronic toxicity to be used to identify that certain drugs are affecting a certain organs for a long period of time. For that purpose only, we are going to perform the chronic toxicity studies. So chronic toxicity indicates specific organ system damage. Specific organ system that eventually the organ remains no longer normal function due to severe damage. There are resulting in many different types of chronic and toxic effects. So that examples of chronic toxicity, so long-term ethanol ingestion in alcoholics. See, better severe effects will be examples are long-term ethanol ingestion for a long time, and then several years of lead exposure in workmen causes kidney diseases, and cigarette smokers develop chronic bronchitis, and pulmonary fibrosis, also known as back lung disease, developed in coal mines. So these studies are performed with the requirement of minimum one rodent or one non-rodent species. So here the animals are separately divided as a rodent and non-rodent species. So while we are going to perform a acute study or subacute study or chronic study, selection of animals are more important. So whether we are taking the rodent species or non-rodent species, we have to identify specifically and we have to select specifically the animals. So that here we are in the especially in the chronic studies, so we are selecting one minimum one rodent and one non-rodent species. And test sample is administered in the animals for over 90 days, periodically observed for the result. So for the result, so we are going to see that. So we have to observe for 90 days approximately for the result. After giving the drug, so the observation period will be 90 days. Okay, so that and this so genotoxicity. So if we observe that there are some toxicity, so some we have seen that subacute, and chronic. So acute means several days. Subacute means it will be for 28 days to 1 week. Sorry, it will be 6 months, and the chronic will be very long. So coming into this, there are some topics under toxicity which gives genotoxicity, carcinotoxicity, teratogenicity, and mutagenicity. See here, genotoxicity describes the property of chemical agents, that damage the genetic information in the cells by mutations or others. So genotoxicity, so normally it is a mutagenicity, that means the changes that the chemicals will bring in the genetic information. So there are some drugs which will affect our genes or which will affect our genetic information. Example like corticosteroids. If the steroids are to be used highly in nature and high in doses, so it will affect the our genetical genes, so damage the genetic information. And then coming to mutagenicity, it refers to induction of mutation, that changes, the changes to be happen by the mutation to permanent transmissible changes. The changes will be happen very permanent. And the genotoxicities, they are to be direct or indirect, they will damage the DNA. So these genotoxins or the substances, they will directly affect the DNA or indirectly affect the DNA. In that, they are categorized into mutagens that cause mutation, carcinogens that cause cancer, teratogens that cause birth defects. Suppose here, so they have mentioned that, so these are the substances and this will be the outcome and this will be the risk. So mutagens are the substances, they cause the mutations, they make change, and the carcinogens, they will have the cancer, and the teratogens, they will cause the birth effects. As the agents are capable of causing direct and indirect damage to DNA, so here are some points that free radicals and then UV ionizing radiation and nucleoside analogs and protein synthesis inhibitors and topoisomerase inhibitors. So these are the substances which are the agents that will directly causes the DNA, directly damage the DNA. So if you observe that genotoxicity mechanism, the damage to the genetic material is caused by the interactions of genotoxic substances with the toxicity. That means whenever these agents, whether it may be free radicals or UV law radiation or nucleoside analogs or protein synthesis inhibitors, so these are the substances that will damage the genetic material because to the interaction of the xenotoxic substances when they are interacted with the DNA. Okay, and these substances interact at a specific location of the genes. We all know that the genetic information has to be encoded in the genes, like that site adenine, guanine, cytosine. These are the four important bases that which gives the genes for the DNA. So whenever the substances like free radicals or the agents that are capable to damage the DNA, they will enter and they will interact with the specific location or base sequence of DNA. It will cause the lesions, break in, fusion, or it will delete the desegregation disjunction of the, leading to damage of DNA. So that the agents, they will enter into the cell, they will attach to the base of the gene, and then they will delete that genes or they will break that or fusion that the structure of DNA. So that genotoxicity and testing cells. So in vitro and in vivo tests which are designed to detect the, so there are some tests in vitro and in vivo tests, they are designed to detect the genotoxic effects of the test compounds. We are going to test the test compound, and these tests enable hazard identification with respect to the damage to DNA and fixation. So genetic toxicology was first published in 1987 following a global update of genetic toxicology, which has been done in 1927, 2013, 2014, 2016. So risk factors for this genotoxicity is somatic cells, which have been getting to aging, and then somatic cells, which are comes under the cardiovascular system, cancer, and the germ cells, which shows the risk in health. Germ cells, which have the risk of sterility, which have multifactorial diseases and genetical diseases, psychosis, diabetes, hemophilia, cystic fibrosis, sickle cell anemia. So these and all the total risks whenever there is a risk of genetics. So it will show these actions. And the xenotoxic chemotherapy, if you observe genotoxic chemotherapy, how this genotoxicity is treated. For the cancer with the use of one or more genotoxic drugs. So alkylating agents, they will interact with the DNA replicate and transmit the DNA bases. So busflon, okay, and then carnosine. And the intercalating agents, darabamicin and doxorubicin. Okay, enzyme inhibitors. So they are inhibit the enzymes that are crucial to DNA or replication. Histamine metabolism. Carcinogens. So carcinogen denotes a chemical substance or a mixture of chemical substance which induce cancer or increase the incidence. So carcinogenicity is the thing. So it is a disease. So it is the toxicology. So it is a toxic substance. Whenever the carcinogens they affect the chemical substances, they affect and they may induce the cancer. Whatever the agents, whatever the substances that may induce the cancer or increase the incidence are called carcinogens, and they will produce the carcinogens to problem. The carcinogens are classified according to their mode of action and genotoxic and non-genotoxic carcinogens. The genotoxic carcinogens make or initiate carcinogenesis by direct interaction with DNA. So they will interact directly with the DNA and it will damage the DNA or chromosomal aberrations that can be detected by the genotoxic test series as the OECD guidelines. So carcinogen classification involves two interrelated determinations, the evaluation of strength of evidence and consideration of all relevant information. So carcinogens are characterized as either known, presumed carcinogens or suspected carcinogens. So category 1 is subdivided based on whether the evidence or classifications is mostly from human or animal. So here we can observe that description category 1 so known to be human carcinogens. So category 1A known to have carcinogenic potential for humans largely based on evidence of human. And the carcinogen category 2 presumed to have the carcinogenic potential for humans largely and based on the evidence of human. So evidence human from and or animal studies is limited, very limited. So here they have mentioned that there are certain carcinogenic agents, that means cancer agents, they are classified into. So European Union classification carcinogens mentioned that according to European Union carcinogen category 1 that may cancer that it causes the cancer of humans. Okay, so they have so European Union has been divided that so these agents are to be differentiated in certain areas and certain functions. So like that, so carcinogen, the agents that are affected with cancer, so they are differentiated as category 1 and category 2 and category 3. Category 1, just the category 1 are the substances which cause cancer in humans. In category 2, it will causes the cancer in animal test. Okay, and most probably humans also. In category 3, it is possible carcinogenic, but evidence supporting carcinogens inadequate for the classification of category 2. Okay, so these are some classes and international agency for research of cancer classification of carcinogens according to IARC. Carcinogens are classified as IARC class 1, IARC class 2A, 2B, and 3 and okay, so here are some agents that are capable for DNA damaging directly or indirectly transferred. So see here, here are some agents which will affect the damage the DNA reactive oxygen species, nucleoside analogs, and the protein synthesis inhibitors, electrophilic species that form covalent andides, and ultraviolet and ionizing radiations. In some herbal plants like equinine, alfalfa, calamus, aloe vera, isofagula, and topoisomerase inhibitors. Okay, and mechanism of carcinogenicity, the interactions of the genotoxic substances like chemical, environmental agents with the DNA structure and sequence results in damaging of genetic material. So, how these carcinogenic animals or which will happen? The carcinogenicity means the chemicals or environmental agents which have the DNA structure and sequence results in damage of genetic material. Okay, and then if you observe the carcinogenic process involves the alteration of four broad categories cancer genes, namely activation of oncogenes, inactivation of tumor suppressors, and evasion of apoptosis genes, and defective DNA repair genes. Okay, that means oncogenes are affected, so activated. That means the agent that causes the cancer they are being activated, and inactivation of tumor suppressors. So in our immunity, there are some cells like T cells. They will suppress the tumors whenever it happen. But what happened? So whenever the carcinogens are affected, the tumor suppressors also inactivated. And evasion of apoptosis genes. The genes that are to be died, they have to be avoided, and then the defective DNA repair genes. So DNA, there will be defective in repair genes. So these are all the conditions that leads to carcinogenicity. So reactive species is also one of the cause leading in the formation of oxidative relations in DNA known as 8-hydroxy deoxyguanosine 8-OHDG protect mutagen resin. So decomposition of primary free radical, intermediate of lipid peroxidation of lipid peroxide radicals results in formation of reactive aldehydes like hydroxynonyl, which is responsible for causing many oxidative stress and related diseases like fibrosis, atherosclerosis, and neurodegenerative diseases. Okay, so after that, so temper will still continue in next class. Thank you.